is in equilibrium. The system is in equilibrium. What is equilibrium? What is equilibrium? What is the meaning of equilibrium? What's that? Yes, you can say that forces that are there, that there's no movement at all. The acceleration is going to be what? Z. I say the first thing you need to do is to identify what? The forces. Let us identify the forces which are acting there. We have this force, we have this force, we have this force, we have the force there. Actually, we have this force there again. Yes. And we have a force there also. Because if this thing is suspended like this, it means there's a force going there. And also there's a force going down. And the fact that there's a force there, it means there's a force there. Again, there's a force going there. Okay. These are the forces which are there. Let's look for other forces which might be there. Let me show my arrows nicely. Nicer. These are the forces. We have 1, 2, 3, 4, 5, 6 forces which are acting that direction. Yes. After we identify the forces in question number 3, we analyze the forces and we study them. We say which forces are in the x motion, which are forces. Let me not use the word x motion. X axis and y axis. This force is acting at an angle, so we need to do what about it? Resolve it, okay? Yeah. This force acting at an angle, resolve it. These are the simple steps that you need to follow. Identify the forces. Systematically So, these forces in a what you call the vertical equilibrium or the vertical, like let's call it the vertical, the y axis, or the vertical equilibrium, or the y axis. Indeed. Oh, let us resolve those forces first. We're going to have this force. We have what? This force again. So we have this force and we have this force. Okay. The force there, this one, is going. So it's going there. So it's going to be negative. It's going to be what? Negative. Y is going there. We can just draw our smaller Cartesian plane here. That y is positive, x is positive, y is negative, x is what? Negative. Mean that the forces which are going there are going to be negative. The forces which are going there are going to be positive. So this force is going to be T1 cos 20, and this force here is going to be T1 sine 20. This force is going to be T2 cos 40. This force is going to be T2, I mean this one is going to be T2 sine 40. Sine 40. And mind you, we are given the first one. Given mass. Are you given mass 2? From the equation, are you given mass 2? No, they are given mass 2. Mass 1 is 6 kg. 6 kg. Okay. Okay. Mass 1 is 6 kg. What we're going to do there is that we need to identify the forces. Okay. If this guy is T2, what is this guy? If this guy is T2, what this guy is what? Is T2. Because it says tension in a pool is the same. Again, earlier is what? The same. That guy is T2, that guy is also T2. Are we together? Are we together? Yes. So we are going to do what? We are going to equate the forces in the vertical. What are the forces in the vertical? this force is acting up, It's acting up and down, It's in the vertical, So it's up. So it's going to be T1 sine 20. Yes. What's the other force in the vertical?
T2 sine 40.
Plus T2 sine 40. Again. T again. And plus this, Plus T2 sine 40. And also
T3.
we have T3, is it plus or it's plus? Is it plus or minus?
Plus.
In which direction is T3 acting? Should it act down again? Yeah, it should be acting down. Yeah, T3E. Sure. Should be acting what? T3 it acts down. And there's a force acting up, and there's this way. T3 is the force is the tension of this spring, which is acting down. So we're going to say minus T3 is equal to mz, which is mean that T1 sine 20 plus T2 sine 40 is equal to T3. That is our equation 1. These are the forces in the vertical. So you should get the forces in the horizontal. The force in the horizontal, get it? What are the forces in the horizontal?
Negative T1 cos 20.
Negative what? Negative T1 cos 20. Then
Negative
plus T2 cos 40. There it is again. So is equal to mz, which means that T2 cos 40 is equal to T1 cos 20. Please. Are we together? Come on, again. Okay. Pause the video.